Okay guys, so today we're going to see some of the exercises that you worked in paper 1. They are not going to go over every single question because I think, for example, number 1, it's a probability question. You probably didn't, most of you didn't have problems with that one. Number 2 also had to do with functions and the inverse function, evaluating a function, and I don't think you guys had trouble with that one either. Number 3 is related with trigonometry, and in this one you were supposed to use sine rule, and there was not much problem there. This one was also pretty easy, so we're not going to go over that one, but we're going to go over number 5, 6, and 7 today. Okay? Number 5 had to do with integrals. So let's take a look at this. This was exercise number 5. Number 5 said for you to find the integral of x times e to the x squared minus 1 of dx. Let me take out a pen so that I can write as we go. Okay? This is the integral that we are looking for. Now, since we have an x multiplying an e to the x squared minus 1, we have to do it by substitution, guys. So we got to take u and equal my u to x squared minus 1. Okay, I got to equal my u to this part. I do the derivative of u and I get du, it's equal to 2x minus dx. And then, since I'm only missing this x dx, I need to isolate it because look guys, I have x here and dx here. So I need to isolate x dx so that I can do the substitution. Then I start my substitution. So I have the integral of e to the u, and then x dx, I substituted it with du over 2. I take out my 1/2, I do the integral of e to the u, which is e to the u, and so my integral is 1/2 e to the u plus c. Do not forget, guys, to put back the value of u so that your final answer is 1/2 e to the x squared minus 1 plus c. Do not forget the plus c, guys. It's fundamental. Otherwise, you will lose a mark there. Now, letter B says for you to find f of x. Given that f prime of x is this. This is exactly the same, guys, as the one that you have on top. And you should know that if you're looking for f of x, well, f of x, it's the integral of the derivative. So the integral of the derivative is the integral of what I had in A. And you already have this answer, which is 1/2 e to the x squared minus 1 plus c. And now, guys, we need to find the value of c. You should know that if I'm giving you f of minus 1, it's equal to 3, what I'm telling you is that whenever my x is minus 1, my y is 3. So I take this function and I substitute. In f of x, I take f of x and I substitute it with 3. While the x, I substitute it with minus 1. I do my e to the minus 1 squared, which that is e to the 0, because it's e to the minus 1 squared minus 1. That gives me e to the 0. E to the 0, it's not 0, guys. E to the 0 is 1. And so I end up with this equation. 3, it's equal to 1/2 plus c. I multiply everything by 2, and I end up with 6 times 6, it's equal to 1 plus 2c. I isolate my c, and I get that c is equal to 5/2. With the value of c, now I can take the function and say that f of x is equal to 1/2 of e to the x squared minus 1 plus 5/2. Or you can write it as 1/2 e to the x squared minus 1 plus 2.5. All right? That was number 5. Then, if we take a look at number 6, let's take a look at number 6, guys. Number 6 said that the following diagram shows a graph of the derivative. This is the derivative graph, guys. All right? Let me go back to the presentation. Here we go. It says the following diagram shows the graph of the derivative. So I'm giving you the derivative graph, not the function, guys. I'm giving you the derivative. All right, remember that the derivative gives you the slopes of the tangent lines. All right, it says the graph of the derivative has a local minimum at A and a local maximum. Let me retake my pen. A local minimum at A and a local maximum at B. And it passes through the point 4, comma minus 2. All right? Letter A says the point P, 4, comma 3, lies on the graph of the function f of the original one, guys. All right? Write down the gradient of the curve of f at P. You guys know that the derivative gives the slope of a tangent line at a specific point. So if it asks for the gradient at P, and you know that P is 4, comma 3, then you need to look at the graph and the y value of your x, whenever x is 4, that would be the gradient. All right? So in this case, if the value of my x is 4, then my minus 2 is representing the slope of the tangent or the gradient of the tangent line. All right? So my answer to letter I would be minus 2. The second one says, find the equation of the normal to the curve of f at f. The slope of the tangent, it's minus 2. Then the normal, guys, we know that the slope of the normal is going to be 1/2. By knowing that it's 1/2, guys, that the slope of the normal, and by knowing that it goes through the point 4, comma 3, then I can substitute in the function y minus y1 is equal to m times x minus x1, and I will get the substitution like this, and then I can just isolate for y, and you would get that y is equal to 1/2 of x plus 1. All right, so that would be the equation of the normal to the curve of f at P. And then the last one, guys, says for you to determine the concavity of the graph of f when x is in between 4 and 5, and to justify the answer. We know, guys, we want the concavity between 4 and 5, so we want the concavity here. We can see, guys, that this is an increasing line, and therefore I can identify that it's concaved up. Another way of solving it, guys, it's by identifying the intervals from negative infinity to a, from a to b, and from b to infinity. What I mean by that is that if I do a sign diagram, guys, I can identify that between negative infinity and a, my graph is decreasing. So if it's decreasing, I know that the slope is negative. Between a and b, I know that the slope is increasing. So that means that my slope is positive. And between b and infinity, it's decreasing again. So I know that it's negative. 4 and 5, between 4 and 5, is in between a and b. So we know that it's going to have a positive slope. And if it has a positive slope, the second derivative, then I know that it's concaved up. If I do that graphically, guys, if I trace the second derivative, what you have is the next thing. You know that at A and at B, you have slopes of 0. So that's why at 0, A and B are the intersections of the x-axis. I have an x-intersection here, and I have the x-intersection here, which is B. And then if it's negative, then you know that it has to be below the y-axis, so it's going to be down here. If it's positive, it's above the y-axis, so it's way up here. And if it's negative again, then it's negative below the y-axis. And that's how we get the second derivative, which is a parabola that looks downwards. Okay, so to determine the concavity of the graph, we can just say that it is an upward concavity. And that is because it is increasing. The graph at this point, or in this interval, it's increasing. Or you can just prove it or justify it with your sign diagram and indicating that the slope between A and B is positive. And then, guys, the last exercise that we're going to see is number 7. Number 7 says, the first 3 terms of a geometric sequence are natural log of x to the 16, natural log of x to the 8, and natural log of x to the 4. Find the common ratio. It's telling you guys that it's a geometric sequence. So if it's a geometric sequence, guys, then you know that the common ratio is this one divided by this one. So you have natural log of x to the 8 divided by natural log of x to the 16. Remember your properties of logarithms, okay? You take, if you have a number as an exponent, you can pull it down as a multiplication right here, and you would end up with 8 natural log of x. Same thing with the 16. You take the 16 and you pull it down right here as a multiplication, and you end up with 16 natural log of x. Natural log of x and natural log of x go away, and you end up with 1/2. So the common ratio would be 1/2. And then letter B says for you to solve this equation right here. It says the sum of 2 to the 5 minus x times natural log of x, it's equal to 64. Okay, first thing you need to identify, guys, is that this is a sum of terms, okay? So if I take this as a sum, a summation, and I substitute the values of k, I would have 2 to the 4 natural log of x plus 2 to the 3, because I'm substituting. First I substituted a 1, then I'm going to substitute a 2, then a 3, a 4, and so on all the way to infinity. Obviously, I'm not going to substitute all the way to infinity. I'm just substituting a few of them. So I would have 2 to the 4 natural log of x plus 2 to the 3 natural log of x plus 2 to the 2 natural log of x plus 2 times natural log of x plus ... because that would be all the way to infinity, but you know that this is equal to 64. Okay? Now 2 to the 4, guys, you know that it's 16. 2 to the 3 is 8. 2 to the 2 is 4. All right? And then the same property that I used for letter A, I'm going to use it, but the other way. This 16, I'm going to pull it up here as an exponent. So now I'm going to have natural log of x to the 16 plus natural log of x to the 8 plus natural log of x to the 4th plus natural log of x to the 2 plus etc. It's equal to 64. Notice, guys, that this sequence right here, it's the same that you have here, natural log of x to the 6. Can you see that? Okay. Once you identify that, guys, you should know that it's a geometric sequence, and it's this same geometric sequence. So that means that the value of r for this sequence is 1/2. And if I know that my value of r, it's 1/2, then I know, guys, that this is an infinite sequence. If it's an infinite sequence, guys, then I can use an infinite sum. And that's where we come to this part. Okay? You know that you can find the sum of an infinite amount of values. If my ratio is less than 1, I can use the infinite sum. And my formula for infinite sum is u1 over 1 minus r. I substitute u1, natural log of x to the 16, 1 minus 1/2. I'm going to do this, but then at the end you got to remember that the sum is equal to 64, guys. Okay? And so I start simplifying this part right here. This right here would be natural log of x to the 16 over 1/2. I multiply the 2, I put it up, so it's 2 natural log of x to the 16. And then this 16, I pull it down multiplying the 2, and so I get 32 natural log of x. But you know that this sum, guys, has to be equal to 64. Therefore, you equal 32 natural log of x equal to 64. And you solve it. 32 is multiplying, I take it dividing, 64 divided by 32 is 2, and then I use my properties of logarithms and exponents, and I turn this into e of 2 of x. Remember, guys, it's the base of the log to this exponent, and it's equal to the value that I have here. And therefore, my value of x would be e to the 2.